Welcome, everybody, to episode number 6 in our AI in e-mobility series. So far, we've heard from chemists on how they use artificial intelligence to design new batteries, find new chemistries. I've spoken to Monolith about AI in EV battery development, heard from Hexagon on battery manufacturing, and Diabetics in the thermal management area. And in this episode, we'll talk about the role of AI in the development of the battery management system, focusing on how the BMS keeps the battery safe and healthy throughout the vehicle's lifetime and what role AI plays in all this. And with me today are Fabrizio Martini, co-founder and CEO of Electra Vehicles, and Mark Ng, who is the director of Automotive Systems team at Texas Instruments. Welcome.
Hello. Hi, Veronika. Hi, Mark.
Awesome. So good to have you here. I think, Fabrizio, you're joining from Italy, and Mark, you're joining from China. So we have a quite unique setup here. Fabrizio, can you tell us a little bit about yourself and Electra Vehicles and what role AI plays in your business?
For sure. Hello, everybody. My name is Fabrizio Martini. I'm the co-founder and CEO at Electra Vehicles. I'm originally from Italy, as Veronika mentioned, and I moved to the United States about 15 years ago, when I've done my master at Northeastern University. And then I started to work for the USA government via the Department of Energy, Department of Defense, and NASA. And during that time, me and my team figured out how there was a massive amount of data that was coming out from batteries and battery packs. And really was in very fast-growing data sets that we thought, how can we leverage these data sets to have better battery design, battery safety, and improve performance overall. So about 8 years ago, we started a company called Electra Vehicles based in Boston, and then started to expand globally because now we are present in Europe, India, and Korea as well. And we develop a brain for batteries. We leverage advanced AI technology that we're going to talk about in order to leverage this massive amount of data, coming out with better battery performance, battery design, battery health, and overall safety.
Thank you, Fabrizio. And I love that you develop a brain for batteries, because when I talk about batteries, I always say the battery is like the heart and the BMS is the brain. Battery chemistry is the heart.
That's perfect description. Heart and brain. Love it.
Yes. So, Mark, we have a long-lasting relationship and history. We have created several videos together, which I very much enjoyed, on BMS technology, but also riding EVs in the desert around Las Vegas. We were also together at CES this year, where Texas Instruments and Electra Vehicles had a booth together, or part of your booth. Can you share a little bit about yourself and your role at Texas Instruments?
Yep. I'm happy to be here, Veronika. As you said, we have a really long history, and we had a lot of fun a couple of years ago at CES, doing donuts in the desert. I'll do a quick plug for you. If anybody hasn't actually seen Veronika's website, it's actually quite beautiful. I'm actually quite envious that I was actually cut out of it, because I'm not in those photos in the front. But I've been in industry for about 25 years. I grew up in the US. I went to school at Santa Clara. Personal reasons, I've moved out and live in Hong Kong right now. And, currently I'm in Shanghai. So basically I'm in the semiconductor industry, which is very different from Fabrizio's background as well as your background. Semiconductors are kind of, we talked about the brain and the heart. I mean, I guess you could call semiconductors like the workhorse or the arms, I guess, right? Just randomly. It's kind of, if we talk in the context of AI or in what's going on in the background with electrified vehicles, I mean, that's really the part that are doing the legwork behind like the BMS, the battery management system, or the traction inverter, or the ADAS circuitry, or, the infotainment systems.
Thank you so much for joining. And I love all the analogies that we're using here, where it seems like we're building a whole body now, like a real human, even though we're talking about AI. So let's first talk a little bit about artificial intelligence in general, how it affects your personal life, if it does, I'm assuming so. And then we'll dive deeper into the use cases from a business perspective. So maybe Fabrizio, how do you define artificial intelligence? Everybody has a sort of their own definition. And how do you use it in your personal life?
Sure thing. So in my opinion, AI is very transformative tool, something that we didn't have years ago, and now we do. And it's going to be the beginning of an amazing era for humanity, because it's extremely powerful. It can do a lot of things, and it can help humanity to become smarter and more intelligent and leverage AI tools to come up with objective quite faster. So in my personal life, I use it to summarize information. We are living in a world of with billions and trillions of information. So I use AI tools to summarize those in a couple of bullet points. I use those in my personal home to understand how I live, how I like to live, and improve my feelings and condition at home. As well as learn faster. And I think we are just at the beginning. So there is going to be a big opportunity to use more and more in our personal life. But what I'm more excited is how AI can really transform the industry and the efficiency of what we do and how we reach destination, how we come up with a new drug, how we come up with a better education system and so on. So there are a lot of opportunities and we are just at the beginning.
Thank you. Love all those examples that you share. Mark, what about you? How does AI help you in your everyday life?
I think for me, AI, I kind of use it for, glorified searching. Just some recent examples. We tend to use Google a lot. And I look at vehicle production data a lot. And basically, I was able to ask, a GPT model, can you tell me what is the latest, production numbers for second quarter across the top 20 OEM manufacturers? And basically, instead of having to do one by one, it was able to pull everything for me and give me all the stats and everything. Of course, it's not going to be correct. And that's where all this machine learning and artificial intelligence is all about. And Fabrizio can tell you more about that stuff, right? But that's how I essentially use it is, just to make my everyday life better. But in the context of electric vehicles, which we'll talk about today, I think it's a very different dynamic, which will change the way that we think of cars altogether.
Absolutely. So I would suggest we'll now dive a little bit into the use case, so the BMS development. But before we talk about how artificial intelligence is actually used, I think I would like to start out to explore a little bit like how does the BMS battery management system development process look like without it? So Mark, maybe you can just give us a little bit of an overview how TI supports customers in the area of BMS development process and what's the traditional way of doing things?
Again, I look at it from a semiconductor perspective. From a battery management perspective, we're looking at an entire battery pack. And in the battery pack, there will be cells, which are really taking up everything inside the pack. And so you need to monitor those cells. And so when we work with our various OEMs or, battery pack manufacturers or tier ones, we're looking primarily at what types of cells they're using, whether it be LFP or NMC. They have different types of specs that they require. For example, a specific temperature range, a specific accuracy that's needed. As we've talked about in our previous videos, like LFP, lithium iron phosphate chemistries require a more accurate estimation of cell voltages and all that stuff. And then our chips basically monitor those cell voltages. Then in the system, there'll be things like high voltage contactors to connect the battery pack to the inverter. There will be basically isolation detection circuitries and all that stuff. And more importantly, as we'll talk about today, is the MCU or the microprocessor, where we would actually put the AI algorithms from Fabrizio's organization, right? And that's where we can do things like edge-based AI or basically cloud-based AI.
And I guess for everybody that really wants to understand the basics of what the BMS is doing and how it all works, I really recommend watch the video that I will link in the podcast here, because I think it really gives a great overview. But just to summarize maybe the functions of a BMS, Mark.
The essence of a BMS is that you need to tell the driver or the whole system how much power is available to the inverter, how much charge is left, how much range is left, what's the health of the battery pack, is it time to service the battery pack and everything. So again, there's the cell voltage measurement, then there's the battery management unit, which is the brain, again, of the system. And then there's also going to be some mechanical components, right? You need to connect and disconnect, and you'll have fuses and so on. So that's kind of like the battery junction box, or the battery disconnect unit.
You mentioned that we have to accurately measure temperatures, currents, voltages to assess state of charge, state of health, range prediction. And now, Fabrizio, can you walk us through the traditional way to assess all those things and then also predict an electric range and battery lifetime?
Sure thing, absolutely. So as Mark said, Texas Instruments developed a series of components, very advanced and novel components that ensure very accurate readings of those current temperature, voltage, that kind of the basic information that you want to collect from a battery to ensure that the battery operates in a very safe environment. And that's extremely important. But there is way more we can do with those data sets. The way that the industry now is taking those accurate measurements is to look at lookup tables that after a specific measurement, connect those measurements to a lookup table to come up with the hard-coded information and come up with the understanding of the state of charge, state of health, remaining useful life of the battery, and the lifespan of the battery. The point is that batteries are a live organism. So when you install a battery, is behaving a certain way, and then over time the battery change behaviors, and actually could have even change vehicle to vehicle. So it's not the same battery and the same changing behavior for the entire fleet. And that's extremely important. That's where really machine learning and AI can really make a big difference. In fact, Electra, basically what we do, we substitute the lookup tables with machine learning at the edge. With Texas System, we demonstrated how we are able to simplify the very complex neural networks to be able to be installed in a chipset in a vehicle and have a machine learning at the edge that continuously learn how the battery is utilized from a driver in a specific environment, because our brain for batteries takes data at 360 degrees. So we take data from the battery, but also from the vehicle, the driver, and the environment. And we feed all these massive amount of data sets into different neural networks that come up into one. So which is the outcome? The outcome is the ability to have a very accurate state of charge with 1% error or less throughout the lifetime of the battery. So the beginning of life, middle of life, and end of life. Versus current technologies, you can start from a 5% error and you end between 15 to 45% error. That means that you don't know if your vehicle will reach destination or not, because the range will be off, right? In particular, at the end of life. That's on the SoC. On the SOA health, we're able to provide a 3% or less accuracy, again, beginning of life, middle of life, and end of life, thanks to a machine learning at the edge with some cloud connectivity as well, in order to retrain the neural network and so on. And this is extremely important because when you want to resell the vehicle, you know the health of your asset, the health of the battery, so you know the value. It's a certificate of health, that's how we call it. And then a series of other advantages. You know exactly the remaining useful life, how many cycles the battery can do before going to service. And with our algorithm, we can actually predict failure up to 3 months in advance. So machine learning AI can really enhance all these great measurements that a company like Texas Instruments can provide and do more and make your vehicle become smarter.
And I guess everybody that drives an electric vehicle, maybe in a cold weather, has experienced how this 5% error can really impact your personal situation. So I think it is so much needed to make improvements there. So you mentioned these lookup tables, which work in a way that you do cell testing, module testing, pack testing during the development before vehicles are even on the road. And you kind of fill those lookup tables because you've tested the cells under certain temperature, voltage, current conditions whatsoever. And then later in the vehicle, you kind of connect this with some type of real-time data measurement. And then at some point, AI and everything comes into the situation. So let's talk about this how AI comes into play a little bit more. So what type of artificial intelligence are we talking about in your specific use cases?
Yeah, so the artificial intelligence we use definitely leverage latest machine learning technology, pattern recognition, as well as advanced neural networks that we own, and we write our own code, proprietary code. Electra now reach a 4-line millions of code within our source code, as well as 10,000 parameters. And a very important aspect of the company is that we reach 1.3 billion data points. The data points that you are referring to is one before the battery is actually even deployed, as you said. So you take a battery, whether from a cell, a module, or a pack, and you do a very deep characterization. So you want to understand the battery, how the batteries behave in every instances. And we call that physics-based model. So we create an exact replica of the battery, a digital twin, that is exactly the same. But then you also want to have the machine learning model. So you combine the physics-based with a data-driven model that is installed at the edge. We actually demonstrate with Texas Instruments the ability to install an ML model into their very advanced chipset that can learn. And instead of looking at the lookup table that are passive and fixed, have outcomes that are continuously getting better and better and better over time. And this is an amazing opportunity because Electra actually demonstrated a Fiat 500e, a production vehicle that I personally drove from Turin, Italy to Paris, London. I did like 7 days with me and my co-pilot, and we demonstrated how machine learning at the edge can really make a big difference in the state of charge, state of health, remaining useful life, and lifespan of the battery. So providing an amazing advantage for everybody who wants to even approach an electric vehicle and utilize an electric vehicle. So big opportunities ahead.
Absolutely. I'm just wondering, like, how do you validate the whole process?
Yes, in our case, validation is key, right? Every time you deploy machine learning, you want to make sure that the brain you develop act properly. And it's kind of doing an exam or a test to a kid that is learning. He goes to school and they go to school and learn, and then they have an exam. We do exam as well. So we do exam at the lab, in the laboratories. We work with a couple of labs in Italy and in Germany, where we validate that the digital twin is actually correct. You do a series of validation at the lab, but then you also want to validate in an actual vehicle. So that's why we install our brain into many vehicles. We have over a dozen of vehicles from different brands, from Korean brands to European to North American brands. And you want to showcase how the machine learning and the data are correct. And you do a series of tests to match what you're reading with what the current BMS is reading. So you do a parallel test, sometimes a ghost unit, sometimes a replacement unit. But in our case, we have seen how our target was 1% error in state of charge, and we were actually getting 0.1, 0.2% error from Turin to London. So extremely precise and validated on an actual vehicle. And hopefully we come to market soon. We estimate start of production 2026 with a couple of players.
It's amazing. Thank you for sharing that. And you just mentioned that you will do, or you're planning another tour here in the US. So what's the goal with that?
Yes, that's an exclusive information, and I give to the audience of Electrified, Veronika. And it's basically, yes, we are going to replicate what we have demonstrated in Europe. It's going to be in the United States. It's going to be a trip from Boston to Las Vegas, CES 2025. Electra will have a booth there. So we welcome you, Veronika, and everybody wants to stop by our booth with a special vehicle. We're very excited about that, and we're getting a lot of traction with OEMs, tier one suppliers, and battery manufacturers, because what's happening in the industry is now the amount of data set is exploding. We have billions and trillions of data, and the companies are sitting up on this pile of gold and information that can really be leveraged by a brain, and that's what we are trying to help our partner to do so.
Okay, so to kind of close the loop again, Mark, for a semiconductor company like Texas Instruments, what is really needed from a hardware and software standpoint to deploy AI algorithms that Electra Vehicles has for BMS development and all those things?
And so as Fabrizio mentioned, he referred a lot to like edge-based AI. When you do that, you basically need to have your sensors. You have to be able to read that sensor data, of course. And then basically all that AI will live in like a microprocessor. And so basically behind the scenes, what you're going to see is like an MCU or MPU. You could be having like a DSP. From TI, we've got like the C6000, C7000 series, like C2000 series. You have like ARM-based CPUs, neural processing units or NPUs. You could have, beyond BMS, you might have some radar chipsets that actually have, processing functions inside of them at the edge. And so those are the types of hardware that you would need to have to run AI-based algorithms, right, in the MPU, MCU. From a software perspective, that would basically require, things like SDKs or software development kits, and TI's got, our Edge AI SDKs. You'll need, of course, valuable partners. I mean, a lot of this in the industry, you need to rely on multiple third parties that develop different types of algorithms or software, tool chain types of things. And then various front ends, right? So we've got, in TI, we've got Edge AI Studio, various other graphical user interfaces that allow people to start developing based on AI models.
Thank you so much for sharing all that. And I guess in the last part of this podcast, I would like to talk a little bit about the future. So, in this series, we really want to talk about real use cases. As much as AI is kind of hyped these days, the goal of the series is really to see where it can generate business value, where is it used already, specifically for us in the battery value chain. So Mark, maybe just again from a very broad perspective of the organization Texas Instruments, where do you see AI being used in the EV and e-mobility space and where it's kind of headed?
There are some really, really cool areas where AI is headed for vehicles specifically. I think first, what we're talking about here, battery management systems, is all about real-time monitoring and control, right? So the ability to detect anomalies, the ability to dynamically detect, cell voltages, be able to do things like predictive maintenance. As Fabrizio mentioned, I can do like large models where I know that some vehicles may be failing at a certain number of cycles or so on. I can do a bunch of learning algorithms there to better predict what's going to happen. And so basically things like batteries or even the traction inverter, things like that can become, safer, more predictable, and just basically easier to use in general. But there are other areas inside of vehicle, right? So, audio, actually, what's happening in this industry right now is a lot of, algorithms to detect, things like voice recognition or, speaker verification, or even things like, speech to text, right? Those are all basic things that we already have in our lives today, but that's basically AI is going to get that better and better. You can also look at like, noise cancellation, right? So I think there's some new technologies out there which basically can kind of, have a person speaking on the phone on the back seat, but the people in the front may not even hear it. So it's kind of like that ability to detect and shift and project different types of white noise that's out there. So that's real-time control and audio. And the other area that we're working on inside of TI is basically perception, right? So perception is in terms of like, distance and depth, various types of semantics, right? So how do we detect the world? And I'm referring to more of things like radar or various sensors where we can really apply things like edge-based AI and be able to classify things around us in a much more accurate fashion. So I think those are the three areas, essentially, real-time monitoring, audio, and like perception-based models.
And thank you for sharing. Fabrizio, any other areas that you with Electra Vehicles are looking at with all the things AI?
As I mentioned at the beginning, I think we are just at the beginning of AI. We have seen the amount of data that are coming from advanced sensor picking up a big time, going exponentially up. And what I've seen is that BMS will continue to come up with newer and newer sensors integrated, whether it's an EIS chipset or acoustic measurement or so on. But the beauty of ML model is that they can intake new advanced measurements. And what I've seen, the evolution of BMS is that initially we didn't have any BMS technology. Then we come up with passive BMS, and I expect that the next big thing will be active and adaptive BMS. And that's where a brain, we call it EVI, our brain is called EVI that we license to our partner, can really make a big difference in the long term. The actual opportunities for the people that leverage electric vehicles is to have a very accurate range, very accurate health of the battery. So if they want to resell their vehicle, it's not based on kilometers or mileage, but it's based on the actual health of the battery. Is my battery at 92%, 88%, 80% needs to be ready for a second life application, as well as, and so they can come up with a dollar amount or a euro amount or a value of their battery packs. And then as Mark was saying, the ability to predict failure and the potentially via a software update that you can download and install, bypass the failure. Instead of doing maintenance, you can actually bypass via software update. So that's an opportunity that we are demonstrating with our partners, as well as or have preventive maintenance. So you can recall a subset of vehicles and only recall those vehicles. So reduce the amount of recalls that is extremely important for OEMs and tier one suppliers.
Is there anything, maybe also from your personal perspective, any kind of emerging AI technologies that you're very excited for, that you believe will be another game changer in the next, 2 or 5 years, or maybe even months?
But first, I would say our brain for battery to deploy it in the world and start showcasing that in production vehicles. That would be a very good opportunity. But I see also federated learning, the ability to use a different chipset in unused vehicles, vehicles that are parked, for example. You can use some of that power to power the ML model, the ability to share trained models, because it's all about training, right? So shared trained model with a very large set of vehicles, potentially multi-brands, and so on. So learning from each other, and then later on potentially some quantum compute. But we are still early for that. So let's focus on now on applied AI and potentially a new sensor, advanced sensor, federated learning, and then later on quantum will come in. But we'll be ready.
We're ready. Awesome. What about you, Mark? Anything else you would like to share?
I think we're right at the, I mean, everybody says this, we're right at the edge of, the cusp of where we can really be with AI. Semiconductors really are going to be the arms and the legs, if you will. But I mean, we talk about this on our website on how semiconductors are really trying to bring edge-based AI to the next level. So there could be a future one day where, for example, you might wake up at 6 a.m. and your sleep monitor is going to be able to tell you, oh, you didn't actually have that much good REM sleep, and your blood glucose level is low. So basically, it'll wake you up a little bit later, maybe 5 minutes to have you more energized throughout the day. And maybe you'll go down to your kitchen, and your kitchen will know what's in your fridge, and it'll tell you, okay, maybe you have your acid level, so you can't have too much meat, so that'll help with your gout situation. And by the time you walk to your car, the car will basically start and know what specific pins or settings you want. It'll drive you to the gym or to work, and so there's just a whole I would say a merging of various industries, if you will, from medical to personal electronics to whatever, bringing together various types of technologies and kind of enhancing our lives. So that I see.
Yes. Thank you so much for sharing. That's exciting too. Well, thank you so much both for joining our discussion today. I'm really excited what's to come in artificial intelligence and e-mobility and batteries in particular. In the next episode, I will speak with a startup called Compredict on how artificial intelligence is used in virtual sensors and software-defined vehicles. So thanks everybody for listening, and see you next time. Bye.
Everybody.
Awesome. Thank you.